that you are watching today is a part of a pre-calculus or a calculus prep series that I'm going to be doing. I know that a lot of students really struggle with a few topics in algebra or in an actual pre-calculus course before they actually get to calculus. So I do want to address those hot topics, if you would. Now, I have already preloaded this unit circle, and you can find a blank unit circle at mathwarehouse.com/unit-circle, and follow along with me if you will. But I'm going to go into some tips and tricks to remembering the unit circle, so that way this does not stop you in your calculus journey. So the one thing you'll notice that I've done first is I underlined the word unit. And the reason why I did that is to tell you there's a reason we call it the unit circle. And the reason why is because it's a circle with a radius of 1. Now, the center of that circle is located at the origin on the Cartesian plane, or, the XY plane, as we so commonly call it. And I can say, this is the x-axis, this is the y-axis. And I have gone ahead and already put some coordinates in there. So this coordinate point right here is the coordinate point 1, 0, because starting from the origin all the way out to this point is 1 unit long, and there's no units in the y-axis, so it's 1, 0. Up here we have 0, 1, similar to the previous coordinate. Now we do not move horizontally in any direction, in the x direction. We only move vertically 1 unit in the y direction, okay? And then over here, we have the opposite of our first coordinate point, so -1, 0, and then we have the coordinate point 0, -1 down here. All right, great. So just establishing the basics of the unit circle. Now, what we can do is start to fill out the rest of this. And what you'll notice is I've put in all those other coordinate spaces, I gave them a denominator of 2 because they all will have a denominator of 2. I also went ahead and put in the 4 important degrees, so 0 degrees, 90 degrees, 180 degrees, 270, and then a full revolution around the unit circle is 360 degrees. I've also put a pi symbol in the space that's adjacent to the degrees, because that's where our radians are going to live, okay? So let's go ahead and start with the degrees, and we're gonna focus solely in quadrant 1 for the time being. Anytime you have a big jump, so your sector is larger than the other sectors, that's a plus 30 degrees from your, they call it the terminal side, or oh God, yeah, I'll just call it the terminal side. So from 0, if I add 30 degrees, this angle right here will be 30, okay? Now in these smaller sectors, we will add 15 to that. And so 30 plus 15 will give us 45. Notice we move another small unit. So we're gonna add 15 to that and we will get 60. And then we have a larger jump. So since it's one of the larger ones, we would add 30, 60 plus 30 gets us 90, okay? And then the same holds for every other part of the unit circle. So 90 plus 30 is 120. If I add 15 to that, I get 135. If I add 15 to that, I get 150. And, I know I'm doing it right because 150 plus 180 will get me, 150 plus 30 degrees will get me 180 degrees, okay? 180 plus 30 is 210 degrees. Add 15 to that, we get 225. Add 15 to that, we get 240. And then this larger segment, the sector going from 240 plus 30 gets us 270. So I'm still right on track. Okay, add 30 to 270 and we get 300 degrees. Add 15, 315. And then 330 degrees, plus one more big jump of 30 degrees, and we get 360, okay? So that's my trick for labeling the degrees. And I know a lot of you are probably you may dread, your feelings towards unit circle may be different depending on what your pre-calculus background is. But I remember in my education, I was just kind of shown this and never really understood how it worked. So hopefully you can walk away from this video today understanding a little bit more of the development of the unit circle. All right. Now we're going to move on to radians. And if you ever forget the pattern that I'm about to tell you, then you should always remember that to go from degrees to radians, you take your degree and you multiply by the quantity pi over 180. Now that's the conversion from degrees to radians. And you just kind of keep that in the back of your mind. But if you don't need that, if you understand these tricks, then you're good to go. So once again, focusing in on quadrant 1. Obviously, if we haven't moved any, that's 0 pi. And in fact, we don't write 0 pi, we just write 0. So I will write 0 here. And then as we rotate counterclockwise or anti-clockwise, we will have the following denominators. So here it will be pi over 6. Here it will be, oh no, what happened? That's okay. Pi over 4, pi over 3, and then pi over 2. All right. So I kind of remember, you just kind of have to remember these digits, 6, 4, 3, 2. 4, 3, 2, obviously they're consecutive, decreasing in whole numbers. And then there is a jump from 6 to 4. But if you remember these denominators, then you remember the denominators in all the other quadrants. And here's how I like to do it. So not jumping ahead too fast, but if we move only to quadrant 2, what I'm going to do is kind of highlight this vertical distance between these lines, segments, okay? And the reason I do that is because I will know that this, if they're connected by this green highlighted segment, then they will have the same denominator. So here at the 120 degrees, we'll have a denominator of 3, this will have a denominator of 4, and this will have a denominator of 6. Now the rule for quadrant 2 numerators, so the numerator rule for radians in quadrant 2 is 1 less than the denominator. Okay, so what's 1 less than 3 is 2. 1 less than 4 is 3. And 1 less than 6 is 5. Oops. Okay, and then a half revolution around the unit circle is just pi units or 180 degrees, okay? All right, so similar to this kind of the green highlight here, if we move into quadrant 3 now, I'm gonna take those horizontal lines and move them vertically now. So all right, we'll have this set up right here. So I'm just dropping a vertical line down here, and then I will copy those denominators, so 6, 4, 3. In quadrant 3, the rule for the numerator is 1 more than the denominator. Okay, so 1 more than 6 is 7, 1 more than 4 is 5, and 1 more than 3 is 4. Okay, and so I'll also highlight here going from, or on the y-axis, what does that have a denominator of? So it has a denominator of 2. 1 more than 2 is 3, so that's 3 pi over 2. Okay, so sticking with this kind of highlighting strategy I got going on. So that's going to be 3, 4, 6. All right. And the rule for the final quadrant, quadrant 4, is 1 less then twice the denominator, okay? So twice 3 is 6. And if I take 1 away from 6, I'll get 5. Twice 4 is 8. 8 minus 1 is 7. And then twice 6 is 12. 12 minus 1 is 11. And a full revolution around the unit circle would end us with 2 pi. All right. So those are my tricks for the radians. All right. So either pause this video or maybe take a screenshot of it because I'm going to erase my highlights here. So that way we don't get confused now that we're going into the coordinates. Okay. So last but certainly not least is the coordinates of all of these points. And once again, we're going to start in the first quadrant because once we establish the rules in the first quadrant, it's pretty easy to establish the rules in all the other quadrants. All right. So starting in the y position, right, I'm going to write the numbers 1, 2, 3, kind of going up the staircase. And then I'm going to hop over to the x position. So I'm hopping over here. So now this is going to be a 1, coming down the stairs, 2, 3. All right. And I always do it in that way. Now, every numerator is going to get a square root. However, the square root of 1 is 1, so that's why you don't see a square root on top of the 1. You will only see square roots on top of 2 and 3. And there you go. There's your quadrant. Now, you could get into some right triangle trigonometry if you would really like to. You know, this angle right here is 30 degrees. And what you could do is, you know, say, well, I know that the horizontal projection of the radius is going to be the cosine of 30 degrees. And the vertical projection, this dotted line here, is going to be the sine of 30 degrees, which is 1/2, okay? And then obviously we know that this radius is always 1. So, you know, you can come over here and be like, all right, well, I remember Pythagorean's theorem. I could square both of these coordinates and the result should be a 1. So I would get 3/4 plus 1/4 is equal to 1. And then, you know, 3/4 plus 1/4 is 1. So, you know, there's the justification of that. All right. Now, what I'm going to do is label out my quadrant 2 with all the x's negative because that is the you know, that's the way the coordinate plane works over here. So I'm going to make all of these negative. And then kind of going back to this highlighting technique, I can draw, you know, from first quadrant to second quadrant and basically copy and paste the coordinates into quadrant 2. But now the x's will all be negative. So this will be negative 1/2 positive root 3. This will be negative root 2, positive root 2, and then negative root 3, positive 1/2. Okay? And once again, it's just a copy and paste directly from the coordinates in quadrant 1 to the coordinates in quadrant 2. All right. Same deal in quadrant 3, except the theme, as you would, or is that the x and y's are both negative. So they're both going to get this lovely addition. And we're going to drag and drop these horizontal lines, make them vertical lines. So this will be, this first coordinate would be negative root 3, negative 1/2. Then negative root 2, negative root 2. My iPad doesn't like it, I guess, when I rest my hand on it. And then we will have negative 1/2, negative root 3. Now, understand, if someone asked me to do this without any tips or tricks, I'd have a really hard time doing this. Now that I'm, you know, have experienced unit circle for many, many years, it's kind of, you know, using these tips and tricks has really been helpful to remembering the unit circle. All right. And then finally, as we go across, we're going to have all the y's are negative over here. And we're just going to copy and paste as we have been doing. And so that's root 3 negative 1/2. Okay. And then as always, you could verify that if you sum the square of these coordinate points and then square root that result, you will always end up with 1. And that is the unit circle. So if I just kind of get rid of a few details here, you will see a completed unit circle. All right. If you have any questions, leave them in the comments, or you can find me in Canvas. But thanks for tuning in.